Alright guys, today's goal, the learner will understand ellipses. We're going to look at the geometry of the ellipse, the translation of ellipses, orbits and eccentricity, and the reflective property of an ellipse. And why ellipses are the paths of planets and comets around the sun or moons around planets. Okay? So let's take a look. Alright, so the main pieces of an ellipse, the center, the vertex, and the focus. The other are, there's going to be points called major or minor. These are co-vertices, or also known as minor vertices. Okay? See on the graphs, they have them here. They have them right here on the graphs. Okay? And the focus are just like the focus on the parabola, the same distance. Okay? Now, these are when it's centered only at 0, 0. So let's look at ones where it's just centered anywhere. Okay, so let's take a look at the next problem. It says find the vertices and the foci of the ellipse. 9x squared plus 4y squared equals 36. Well, you need it to equal 1, so you need to divide each piece by 36. So you would get x squared over 4 plus y squared over 9 equals 1. So now we know a is 3 and b is 2, because you know b squared is 4, a squared is 9. So to get c squared equals a squared minus b squared, so c squared equals 5, so c is square root of 5. So the vertices, the major vertices, are (0, 3, 0, -3). The minor vertices are (-2, 0, 2, 0). And then the foci, well, they're going to be h, so h, 0, k, 0. It's h plus or minus, oh, nope, sorry. It's h, comma, k plus or minus c. So the foci are going to be 0, comma, plus or negative square root 5, and 0, comma, square root 5. Okay? So let's figure out how we can graph one. Okay, let's look at the next problem. Alright, so it says find an equation of an ellipse whose foci are (-2, 0, and 2, 0, whose minor axis has a length of 2. Okay, so let's look to see real quick what that minor axis is. Okay. The minor axis for this graph would be right here, the whole distance. The major axis for this graph would be here, because it's the longer one is major, the shorter one is minor, okay? So, if the length of that is 2, then we know b equals half of it. So we know b is 1, and I know c, if I look at the foci, well, (-2 squared is 4 and 2 squared is 4, so I know c is 2. And I know k is 0 and h is 0, because remember, for the foci we know h plus c equaled 2. And since they're both 2 and (-2), h has to be 0. So 0 plus c equals 2, so c equals 2. So if I know b is 1 and c is 2, then 2 squared equals a squared minus b squared. 4 equals a squared minus 1. Add the 1, so you get a squared is 5. So our equation then x squared over 5 plus y squared over 1 equals 1. Alright, one more problem. It says find the center, vertices, and foci of the ellipse. Okay, so center, h comma k, so the center is negative 1 comma 1. Well, I know A is 3 and B is 2. So then I know c squared equals 9 minus 4. So c is the square root of 5. So then the foci would be h, which is negative 1, comma, k, which is positive 1, minus the square root of 5, and negative 1, 1 plus the square root of 5. So there's our foci, there's our center. Now the major vertices are going to be h comma k plus or minus a, so plus or minus 3. So our major vertex here is negative 1 comma negative 2 and negative 1 comma 4. And then our minor vertices are h plus or minus b comma k. So you get negative 3 comma 1 and 1 comma 1. So there's everything. To graph it, all you got to do is plot your foci, your major and minor vertices, and draw the shape and the center. Okay? So let's look at an example here. Here's an equation that we might need to know. Okay? It says the eccentricity of an ellipse is E equals C divided by A, which equals square root of A squared minus B squared over A, where A is the semi-major axis. So semi-major axis is half the major axis. B is the semi-minor axis, so it's half the minor axis. And C is the distance from the center of the ellipse to either focus. So that's what they're talking about, okay? So just understand eccentricity and what these pieces mean. See you guys in class.